everybody, welcome back. So today we're going to be talking about some special inequalities. So you might have learned inequalities before, but like you might have learned how to deal with them, how to manipulate them, but today we're going to be talking about some special ones that you might not understand right away. Some of them will go over the proofs, some of them we won't, but knowing them is really important sometimes. So first, I want to just start off with some basics. So let's say we had a sequence AI, which is equal to A1, B, or A2. Yeah, A1, A2, A3, dot dot dot, all the way to AN. Now, let's say you add another sequence, BI, which is equal to B1, B2, B3, so on to Bn. Right? We're mainly going to just use AI, but we might sometimes have to use two sequences, so Bi might come in. So, I also want to introduce you to some other things, like some means. Like you might know the arithmetic mean or the arithmetic mean, which is called the average, but that's not the only mean. There are three more means. So there's a arithmetic mean, or AM, which is equal to A1 plus A2 plus dot 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 plus AN over N. So you add some numbers and you divide by however many numbers there are. Right? Then there's a GM, which is kind of like the AM, but instead of over N, you do the nth root. And instead of adding them all, you multiply them all. So you have A1 times A2 times A3 dot 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 times AN. Okay, now these are the main two, but there are two more. The next one is going to be the QM, or the RMS. So the first one was AM, arithmetic mean. Second one is GM, or geometric mean. Third one is QM, or RMS, or you can call it the quadratic mean. You can also call it the RMS, which means the root mean squared, but QM is shorter. So this is the square root, or so this is so the QM is pretty simple. Not the easiest to see why, but it's just a square root of A1 squared plus A2 squared plus dot 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 plus AN squared. You might be wondering, why does this kind of thing exist? And by the way, all over N. It's kind of like this. It's kind of like the AM, but GM kind of like put in, but yeah, it's kind of weird. And some squares, and instead of nth root is square root. But yeah, then there's the HM, which you also use. QM you don't really use much, only in inequalities kind of. But HM you use in rates. So HM is the n divided by the reciprocals of all the things. So A1 plus 1 over A2 plus 1 over A3 plus dot 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 plus 1 over AN. Okay. Might be wondering, why does this one exist? Well, when you have two rates, like Sally goes to John's house at 30 miles per hour, and for half of the trip, and then the other half goes for 40 miles per hour. What's the average, or stuff like those kind of things, where you can't just use the AM, the arithmetic mean. You have to use HM. So now we know all these, and now I want to introduce you to some of the inequalities. But I kind of want to rearrange this because right now this is not in the best. This takes up a lot of space. Oh, come on. So we're going to take this and we're going to move it right there. Maybe shrink it. No, we can't shrink it. Okay. Then we're going to take another one of these. We're going to take this one. Sorry. Yeah, we're going to take this one. Take this. And bada boom, bada bam. What? Why don't this move? This. I don't know why this isn't working. Oh well. Yeah, hopefully you guys know this by now, right? I'll just rewrite it, whatever. So we have our sequences AI and BI. And hopefully you know what that notation means. As I'm recording this, I haven't recorded the previous things, like what AI and BI mean, but they will come up at some point in life. So yeah, so now AM, oh, come on. Yeah, so AM equals A1 plus A2 plus dot 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 plus AN all over N. GM equals this nth root of A1, A2 dot 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 AN. HM equals N over 1 over A1 plus 1 over A2 plus dot 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 plus 1 over AN. And then QM equals the square root of A1 squared plus A2 squared plus dot 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 plus AN squared all over N. Well, not all, but just that part. Now we're gonna put some dividers. We're gonna do that, that, and that. So now we know this. So now I'm gonna introduce you to the AMGM. Or actually, first I'm gonna introduce you to the trivial inequality. So the trivial inequality and trust me, when you see it, it is trivial. Trivial inequality states that x squared is greater than or equal to 0. Did you know that? It's crazy, right? And I'm gonna use some abbreviation. So I'm gonna say E with another line through it, and that means equality. Or yeah, I'm gonna do it like that. That means equality holds when. So here's a notation that I just created. And equality holds when this is not really the real notation. I just made it up. I just made my own now. So equality holds when x equals 0. Okay, cool. When x is less than 0, we know when negative times negative is positive. Done. If x is greater than 0, of course positive times positive is positive. And we also know when x is equal to 0, it is the x squared 0. Okay. Now I'm going to talk about the AM-GM inequality. Of course, we're going to be using AM and GM. So it basically says that AM is greater than or equal to GM. So let's just square that one, or rectangle that one. And equality holds when A1 equals A2 equals A3 equals so on to AN. We did it, guys. Next one. I could prove the AMGM using painful algebra, but no. So, like I said, some of these I'm going to prove, some of them I won't. Next one is the triangle inequality. So the triangle inequality, so this is really algebraic. I will prove it, I will show the algebraic one, but triangle inequality basically says that if you have some random triangle, okay, and the side lengths are A, B, and C, it shows that A plus B, oh wait, what am I doing? Sorry. A plus B is greater than C, B plus C is greater than A plus C is greater than B. So why is this helpful? Well, when you have something like this, then A, B, and C, then we know that obviously we know that C is greater than A and C is greater than B. So if C is greater than A and C is greater than B by looking at a picture, then obviously we know that A plus C is greater than B because C is already greater than B. And we also know that, and same thing for C plus B is greater than A. We have that so how to make geometry into algebra? Well, the first thing that comes to my mind is the coordinate plane. Coordinate plane. So obviously, so if we had some random triangle, hold on. Yeah, let's say we had some random triangle. Let's say it was like this, and then like this, and then like that. We know that we can just move one of the vertices to the origin. Of course, this is a transformation, or a translation in this case, but it's so hard to draw small. Anyways, yeah, so they're the same thing. You just move it here. They have the same areas, same perimeter, same length, same angles, everything. So I'm gonna just remove that. So now let's draw that same triangle. Now let's say we had the side lengths of, actually no side lengths right now. Because we're on the coordinate plane, we like points. So this is 0, 0. This is A, comma B. This is C, comma D. Now, this length over here, we can use distance formula, but because one point is 0, 0, this is just a square root of A squared plus B squared. Same thing here, this is just a square root of C squared plus D squared. What's cool is that we can use these right triangles to help with our other triangles. But now this length, that's not really, that's not to the origin. So this is the square root of A minus C squared plus B minus D squared. So now using the triangle inequality, we get the fact that the square root of A squared plus B squared is plus the square root of C squared plus D squared is greater than the square root of A minus A minus C squared plus B minus D squared. Okay, so now this is the most important case. So now let's expand some things, square both sides. We square both sides, we get A squared plus B squared plus C squared plus D squared plus, don't forget the 2 times both the terms, 2 times the square root of A squared plus B squared times C squared plus D squared. Expand it using FOIL, we get A squared C squared plus A squared D squared plus B squared C squared plus B squared D squared. Yay! This is great. And that, of course, is greater than, we square that side. We can also expand it. We're going to get A squared plus B squared plus C squared plus D squared minus 2 AC minus 2 BD. Now I'm going to do something. First of all, I'm going to factor this into negative 2 times AC plus BD. Second, they both have a squared plus b squared plus c squared plus d squared. So we can remove all of those. Yes. Now we can divide by 2. Right? And this 2 goes away and this becomes negative. Now, notice that if you were to square both sides, this negative would just go away, right? Because a negative squared is a positive version of that thing squared. So let's say this is x, or actually let's say this is w. Then we know that negative w squared is equal to negative 1 squared times w squared, which is equal to 1 times w squared, which is equal to w squared. Hopefully, I think you guys knew that. I just wanted to show you that really fast. So now, forget w. So now we square both sides and we get a squared c squared plus, I'm going to put b squared d squared first. B squared d squared plus a squared d squared plus b squared c squared is greater than a squared c squared, right, we're squaring this, plus b squared d squared plus 2abcd. Notice, gone, 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 gone. And all we have left is AD squared plus BC squared is greater than 2ABCD. Now, this might not seem obvious at first, but this is actually really obvious. It's just as trivial as a trivial inequality, if I were to be honest. Why? Because let's say AD equals x and BC equals y. We'd have x squared plus y squared is greater than 2xy. Why is this trivial? Well, minus 2xy on both sides, we get x minus y whole squared is greater than 0. Why is that trivial? Well, that is a trivial inequality. We have something squared is greater than 0. Say this is z, so we have z squared is greater than 0. That's a trivial inequality. That's really that's basic, right? I thought you guys said that was trivial. Or at least in my mind you say that was trivial. Well, I actually wrote things pretty big here. But anyways, yeah, that's supposed to be trivial, right? So now you might use some of these. So you might use the fact that x squared plus y squared is greater than 2xy. AD squared plus BC squared is greater than 2ABCD. Most of these are kind of like you just cancel things out and to get another one. You might use this one sometimes, but the main thing that you're going to use is the triangle inequality when it's in its geometric form. But in its algebraic form, it's just saying that AD squared plus BC squared is greater than 2ABCD. So that's a triangle inequality. The reason why it's so big is because I did the whole thing. This is one of those where I did the proof. AMGM. Okay, now the next thing I want to talk about is called the mean inequality chain. The mean inequality chain is just saying that AM is greater than or equal, no AM, forget AM. Sorry, actually remember AM. Remember all the means this time. Instead of just AM and GM, we're going to use all of them. So we're going to say QM is greater than or equal to AM, which is greater than or equal to GM, which is greater than or equal to HM. This is the AM-GM inequality, right? And because the equality holds in AM-GM when all of them are equal, all the terms are equal, it must hold in this case too. So equality holds when A1 equals A2 equals A3 equals so on, which equals AN. Next thing I want to talk about, it's called the Cauchy-Schwarz inequality. Cauchy-Schwarz is usually complicated at first, so I'm not gonna do the proof for it either, but just look at it. Now we're gonna use two sequences. So we have A1 squared plus A2 squared plus plus AN squared is greater than or equal to or sorry, no greater than or equal to. That is times b1 squared plus b2 squared plus dot 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 plus bn squared is greater than or equal to a1 b1 plus a2 b2 plus plus all the way to an bn all squared. And yeah, and equality doesn't hold when they're all equal this time. Equality holds when a1 is equal to b, or sorry, yeah, sorry, no, ai is equal to bi times n. So that means that ai and bi, one of them is a multiple of the other. So like 1, 2, 3, 4, and 2, 4, 6, 8, like that. A special case of this is when all of the bi terms are just 1. In that case, we're gonna have another special thing. Well, that's not really an inequality, but you use this one a lot. You get a1 squared plus a2 squared plus dot 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 all times n is greater than or equal to a1 squared plus a1 plus a2 plus dot 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 plus an squared. This middle term, this term is just using our series. We get a1 plus an over 2 times n. So yeah, that's that inequality. Now there are 2 more to go. The next one, the next one is called the rearrangement inequality. Actually, I'm not gonna write it there. I'm gonna write it out here. So now the rearrangement inequality is pretty cool. So we have our 2 sequences, right? It basically says it basically says that a1 b1 plus a2 b2 plus dot 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 plus an bn is greater than a1 bn plus a2 bn minus 1 plus dot 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 plus an b1. And actually, in in any combination of this type of form, this is always a maximum and this is always a minimum. And that's called the rearrangement inequality. You might be wondering, when am I going to use this one? You might use it a lot. You just need to be able to recognize it. Final inequality is the power mean inequality. The power mean inequality, it's really hard to memorize, but so the power mean inequality is probably the hardest one to memorize, and it's kind of like a combination of all of them, kind of, and most of these that you've learned are really just special cases of this. So the power inequality states that x1 we were using 8, right? So a1 to the r plus a2 to the r plus a3 to the r plus dot 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 plus an to the r all over n all to the 1 over r is greater than or equal to x1 or a1 to the s plus a2 to the s plus a3 to the s plus dot 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 plus an to the s over n all to the 1 over s, where r is greater than s. Yeah, so this is like the big boy that it's like the general case. It's like the general of the general cases. So first of all, do not rely on these too much. And I just find the beauty in the symmetry of them. And yeah, and I know you guys probably are still feeling like, when am I going to use this? So I want you to prove that a squared. So I want you to prove two things. Prove that where a, b, c, and d are real numbers, then a squared plus b squared times c squared plus d squared is greater than equal to ac plus bd squared. Also, find where they're equal. And I also want you to try one more thing. Also try to prove that prove b over a squared plus a over b squared is greater than or equal to 1 over a plus b. Sorry, 1 over a plus 1 over b. Yeah, so thanks for watching, and I'll see you guys next time. Goodbye. Goodbye. I'll give you the answers in the next one.